So thank you. Appreciate the opportunity to speak in front of you today, and also thanks for the opportunity to act as a sponsor to UKNOF. So I'm going to try and talk about a subject that is a subject of major hype in the industry. I'm sure you're all aware of NFV, Network Function Virtualization. Rather than banging on about app stores, I'm going to try and talk to you about how to mitigate risk if you're an early adopter. So first of all, I'm just going to start out with a bit of what are we trying to do, just in case nobody has heard of this. I doubt that's the case. But what we're trying to do is take physical network functions. We're going to try and virtualize those. That means instantiate those things in software, and then run those as virtual networking functions on NFV infrastructure, which really means virtual machines on top of hypervisors on servers. Now, I think our IT guys actually created this slide for me because I kept losing my key fob. I know Matt was talking about the YubiKey earlier. I would just lose it. So I was quite encouraged when they gave me a mobile phone app to run my RSA key fob on. Stops me from losing it. So this is probably the only slide with what looks like an app store, but I'm really not going to talk about the app store side. What are the benefits of virtualization? So to me, the key benefit of virtualization is the ability to introduce new services and modify those services very quickly. But some of the slides here just talk about some of the alternative benefits. One of the key benefits is around the choice of hardware on which you can run your once physical appliances when you virtualize them. So it's the ability to run them on compute-enabled platforms, be they COTS servers, be they servers that are designed for enterprise, or be they high-end devices within the network. Basically choose any platform or brand. Another key benefit of NFV and virtualization is the choice of location on which you place these VNFs. So you're no longer constrained to having routers at the edge. So CPU routers could be migrated deeper into the network. They might be hosted on the edge of the network for valid reasons. You can even move them deeper into the cloud. Obviously, you might suffer latency effects as a result of that. But the point is, you can place these VNFs where you need them or where you want them. So it's about choice of location. Now, I don't want to try and pretend that everything can be virtualized. In fact, far from it. So really, what are the kind of things to bear in mind? The caveat that I would like to say is, if you are introducing functions that have a limited lifetime, perhaps elastic services, you're changing the parameters around the service quite quickly, or you're tweaking the algorithm from time to time, or it's a moderate processing load. That would be a case where NFV would work for you. So, for example, CPE devices at the edge of the network could fall into that category. On the other hand, where you've got dedicated hardware, so static functions that are always on, you're never going to change them, you might want to optimize those into hardware. So categories like performance-sensitive, delay-critical services might not be the best candidate to virtualize. And another key one for my side is synchronization. With the BT discussion earlier and also some of the mobile guys in the room, if you try and virtualize synchronization, it might not be a wise thing to do. So for example, core routers and the like, for now, probably not the best candidates for virtualizing. Now, I'd like to talk, as I said, about mitigating risk in the network for new adopters. And I've got some examples here. It's not meant to be an all-encompassing list. I'm sure you've got your own examples of pitfalls that people might fall into. But to me, the kind of obvious ones were, if I've got a compute platform on top of a device, I might see failures of that server, that compute platform. How do I handle the event where the server falls over on top of the box? What happens about software instability? So I've got a number of different VNFs running from different vendors. Something's not working. How do I know which vendor to go and speak to about which VNF is not performing well? If I move things from a physical world up inside a software stack and put it further up the stack, I'm going to suffer latency issues, so challenges around latency. How do I actually manage latency and the impact of adopting NFV? Another example of the challenges and pitfalls that people might fall into is, once I've started to go down this path of deploying NFV, how do I actually manage and orchestrate the whole thing? Do I go for one big bang global orchestrator and do a lot of investment to make that work? Or am I better to go down domain orchestration paths? So I do a divide and conquer approach. And I don't think there's a one-size-fits-all strategy that I could pick that is, the one to go for. I think it's be flexible and pick the manner that is right for you. The other one that I keep coming across is marketing challenges. So certainly within MEF, Metro Ethernet Forum, there's a bit of discussion about virtualizing the uni, virtualizing the NID. So if I virtualize my uni and put it inside a virtual machine, and then put a loopback on that user network interface inside the virtual machine, what have I actually done when I put that port into loopback? Have I verified the circuit at the end of the customer's network? Not really. It's a virtual uni living in a software stack. So I wouldn't be surprised if customers come along and say, but I'm paying for a physical uni and you've put a loopback on my virtual uni, but you've not actually proven my circuit at all. So just beware of marketing challenges as well. So with that said, some of the things that you might use to mitigate some of those risks. To our view with NFV and virtualization, there's two directions that you could pick. There's a pure play variant, which allows you to put virtual networking functions on, as I said, choice of hardware, choice of brand. So this is about putting apps on top of COT servers. Another alternative to that is to do it in an assured way. So this is about integrating the compute platform with the actual forwarding plane that compute platform is running on top of. That might allow you, or does allow you, to actually implement alternatives to some of the VNF or NFV infrastructure, like Open Virtual Switch. You can start to accelerate the Open Virtual Switch, possibly even move it down to do it in hardware. That, in theory, frees up your NFV infrastructure, your compute facility that you've actually put down there to host virtual networking functions. By deploying assurance, you can actually free the resources up to make better use of that compute facility. So it's really, you've got two choices really. It's about pure play, gives you flexibility and freedom of choice of brand and hardware, and assurance gives you flexibility and performance as well. So just to try and sum up, I think it's really all about choice, is my view on NFV. How you mitigate risk is you've got to make some choices and be flexible. So it's about choices of which appliances do you virtualize, which location do you place those virtual functions in, which platforms do you host them on top of, and do you go down a pure play or an assurance route. And I think in the case of early adopters, I would definitely recommend going down an assurance route. Above all, I think the key thing in NFV is about openness and interoperability. So make sure that anything you do breeds openness and allows you to prove interoperability. So it gives you insight into the VNF infrastructure. You can isolate VNFs, etc. So ADVA are going to be doing we've got a stand outside the room. Alan is on the stand. He's going to be able to talk you through some of our facilities and our devices within this market. We can show you it. I'd just like to say, although it's about NFV, that this is actually real. It's outside on the stand now. It's here today. Please come and see the stand. And thank you, and I'll leave you to go and get lunch now. Unless there's any questions, of course.